So what you see here is the same look and feel that Matt just showed you in this at a glance view of everything that just happened on a specific subnet that I was running this test on. I was specifically running the ransomware emulation framework. And what I'm seeing here is something that Pentera immediately discovered 17 devices. No agents required. Pentera can run without any agents installed across your entire network-wide infrastructure. From there, once we found those assets, we want to start triggering the attack, the same way as the attacker would. And you see here on the left side, there were 234 achievements that were built for all of these assets. And I can take a quick view on each one of those assets because I know this is a critical server and I want to know specifically what happened on this specific environment. But if I click here on the top left, completed ransomware attack kill chain on the host, I see here that there's a specific host that we were able to complete a ransomware emulation framework, and 15 others which we were not able for multiple reasons, whether the controls were operating as they should, and that's a good thing. At the end of the day, we want to validate your successes. We don't want to validate failures. Sometimes we do need to do that so we can go and fix that, but we want to make sure that your intent, the way you design the architecture, whatever it's zero trust, defense in depth, whatever architecture you're using, we are validating that it's working as designed. So if I look at this attack map, completed ransomware, I'm going to zoom in just a minute so you can guys see the entire details, and I'm going to walk you through. There's an option to see the adversary level, and I'm going to click on that quickly to show you. We have mapped each one of the techniques based on their stealthiness, based on their skill set required to operate them, and what we're seeing in the wild to who's really doing that type of tactics and techniques. But you can quickly change it to a moderate technique. Let's just keep it moderate technique because this is something that's more appealing to me personally. And the first thing that Pentera does, you can see that once Pentera is in, we started opening a remote control channel on the host so we can start kicking the attack using an NTLM authentication protocol. From there, we continue, progress the attack, and see how wide and deep can we go. We start executing remotely on the host. You can see here the actual execution that we've done. And here, at this point in time, Pentera is operating as your local command and control. There's a beacon established between that agent to the Pentera system, so we can continue now operating and doing and launching new attack framework on that host. From there, we see that we're able to upload malware to a host via living of the land binaries. You can see here the injected files that we've used, and here you can also see that your endpoint controls, whatever the alphabet soup of the day is, EPP, EDR, AV, was not able to block that action. Now there's many reasons for that. Either we were able to bypass that, either it was not set up for prevention, only detection, and then you need to make sure that your blue team actually found that event in any monitor tools that you're using. But this is an indicator that needs to turn on a red light for you guys and see right at the beginning of the flow, you should have cut the kill chain already here. Let's continue. Once we've uploaded the malware to a host, we are going to start Pentera executing code remotely on the host. From here, we start payload establishing connection to Pentera command and control server. Again, getting more information because right now there's more information that Pentera was able to gather alongside the attack, and further actions can be taken. Whether you allowed automated approval on those actions or you need to manually do that. It depends on you. The granularity from options is there. And here, once we establish that connection, we're gonna inject payloads to remote processes to gain stealthiness and actually start doing the ransomware attack the same way as the ransomware strains are doing that today. What's happening next? We're generating the encryption key. You can see here, we have the encryption key available for you, the SALSA 20, as I mentioned, the algorithm that's being used. And once we were able to generate the encryption key, we want to start on those hosts that we were able to discover and do all those actions on, which files are out there? Pentera allows you the flexibility to identify which files you want to go and perform the encryption and data exfiltration on, and there's flexibility there. So if your company name is Acme Corp and you have dedicated files .acme _ corp, you can definitely do that. There's highly flexible and configuration available there. So we enumerated the files. Now, after I know what I want to, I saw what I need to, what I was able to find, I want to go and encrypt those files. So I'm encrypting those files, and I'm also allowing Pentera to do configuration on such as registry keys on the system, because I want to start getting persistency. And in case the user already now interact with me and trying to interfere, I am gaining the right persistency. So in case a reboot happens or anything happens, I don't need to go through that process again. This is a typical step that an adversary would take in this case. From there, creating a mutex object mutual exclusion, usually being done there. And now I'm trying to exfiltrate data to known IOCs. You can see here, we allow you to do the same IOCs. Now again, nothing is being exfiltrated. This is the known IOCs that we're sending an hello world type of a message outbound to make sure that our egress controls and NDR and everything that's sitting on the edge is actually blocking the type of network, that your threat intel is up to date. This is the end-to-end view. And as you can see here, I was going through that pretty fast, but none of these steps were actually blocked by the existing controls. That's a problem. Your controls, as part of the way you design the security program, have so many ways to stop the attack in each one of those steps, and it didn't. And here, we're emulating shadow copies deletion. We're not going to touch it. It's completely safe. We want to make sure that you know that we touched it. That means that we can access, and the ransomware in that case can cripple that host to a point when you cannot recover from that using the shadow copies. Whether you have data recovery or other options, that's great, but that is an option you cannot be counting on in that case, eventually leading to a complete ransomware attack, a full chain of events from initial access all the way to lateral movement across your entire subnet that we've tested on, elevating privileges, infecting the device, and command and control encryption, all the way to completing the ransomware attack. Now, very quickly, before I open it up for questions and kind of last thoughts, is the same thing as Matt said. What you have here within the MITRE tab is the actions that we've taken relevant only to this ransomware test. The techniques and sub-techniques that's being used, obfuscated files, software discovery that we've done, file transfer protocol and application layer, the exfiltration over alternative protocols. But you have now that view, and you can say and hold your controls accountable to, wait, what just happened? I know that you guys, this control should have stopped this. Why this was allowed in, or a blue team did not receive an alert, saw an indicator, or it was not being prevented to begin with because that may be not the configuration in place, or the control is lagging behind. Last thing that I want to show you is how do you consume that, and how do you know where to go next? Because I just showed you more problems. I want to actually show you what is the key things that you're able to understand from that. So within the report that's generated in real time, you can see more information about the specific ransomware strain here. And the executive summary tells you about the resilience score, but we're focusing here on 4 key things. How many achievements and the criticality of those achievements, how we're able to bypass controls, regardless to the controls you have in place, how deep and wide, how many hosts were able to accomplish the ransomware attack on, in this case 17 hosts, but to be honest, it can be 17, it can be 5,000. If those are touching your critical servers, which you have configured with Pentera, even one is a major risk and should be accounted for. But that helps you understand and evaluate how big the impact may be, and whether it's not just the encryption side, it's how, whether you're able to accomplish the data exfiltration as well. and giving you all those indicated from a payload, enumeration, manipulation, encryption, and so on and so forth. I'm now wanna just quickly pivot to questions in just a bit, but as a call to action for you guys, if you're interested to start trying Pentera and actually try for yourself whether you are ransomware ready, the best way is to use our free ransomware readiness assessment that I want to kind of put it out there right now. This is a one-day proof of value that we can help you evaluate whether you're ready or not and really answer that question confidently. You're getting way more, but this is something I want to put out there. So thank you very much. And without further ado, Carol, probably over to you in case there's any questions that were thrown in the chat.